2 days. It was a hackathon hosted by Banca Transilvania, the Techsylvania Hackathon. I think it was the 2nd edition. And amazing things happened in a period of 24 hours. I know that you would say 16, but officially, technically, it was, let's just handshake on 20. Yeah, okay. Okay, so what happened is we got a bunch of geeks together, a bunch of developers, and we provided gadgets, toys, we put them at their disposal, and they got to play around for 24 hours, 20, and hack together different ideas that they had previously, and build cool little things. That the winners, the number 1 and 2, the first 2 winners of the hackathon are going to present here tonight. And the first idea, the winner of the hackathon is a project called Greenbox, and they build the product that will convince you to use renewable energy for your home. And I'm going to pass it on to Jon now, and they're going to do also a little demo. And afterwards, if you have questions for them, I think they would prefer technical questions, not necessarily a business model validation question, because they didn't focus on the business side of the product. So if you have technical questions for them or suggestions, you will be most welcome to do so. So, Jon?
Thank you very much. Okay, so my name is Jan Paul Pirou. I'm the presenter for the Green team. I'm together here with my colleagues, Onet Andrei, Gonikman Mihail, and Jakob Scholl. We have spent this weekend working on our project, which is called Greenbox. And basically, this project, as my colleague said earlier, aims to convince you to use renewable energy in powering your home. So, climate change is real. Basically, we are living in a society that spills a lot of CO2 in the atmosphere to fuel its growth and its need to increase and to grow further. Most of this energy, of this CO2 is spent with producing energy for the industries, for the homes, and also for all the other industry. So basically, the Green Box is a project that is, as a user, you can put it on your rooftop, and based on the solar power and the wind power that you have available on your location, over a period of time, it will calculate a recommendation for you on how efficient an installation of renewable energy will be on your location. So I'm going to ask my colleagues to show you the readings that we've obtained with the device by, let's say, sampling the power in the lobby. Okay, so we have a technical difficulty. Basically, I'm going to tell you we need more than 100 years to keep some solar panels in the lobby in order to get some return on investment on that. Okay, so basically, you can notice the device has a solar panel, wind gauge, wind sensor, and when the solar panel gets light, you will notice that the solar output will spike. So basically, what this does is it takes all these readings and sends it to a backend. The backend stores it on a server, on a database. Then the server contains some algorithms which will calculate based on the parameters of the local power grid price and also the cost of an installation. It will calculate how much time will be necessary for you to have the return on investment. So if you can show the recommendations page, please. Okay, so we sampled the data. Okay, so this is the recommendations page. Basically, unfortunately, yeah, it's not very visible, but it actually calculates based on the red data in how much time you'll get the solar output to match the cost for your installation. Okay, if you can also show the configurations page. So basically in this equation there are some factors like the price of a solar panel, the price of an inverter, price of the batteries, and also the price for a wind power generator. All this will factor into the total cost that you will have for a solar and or wind power installation. And based on the price of the power in your region, or in your country, you will basically be able to calculate the return on investment. So, yeah, I'm trying not to get very technical in the details, but if you have any questions for our demo or for how we built it, please feel free to ask the question. So if you raise a hand, then I think you will get a microphone.
Okay, thank you guys. Do you have any questions for them? How many technical people are in the room? Come on, geeks.
There's a question there. So, yeah, thank you very much for the question. The question was if it's supposed to work as a finished product right now. So basically we worked for 16 hours. We had just a bunch of sensors and a board on it. The idea is of having ultimately a finished product. It can be a finished product, but right now as it is, it needs some tweaking, a different box so that it's resistant to the weather. And yeah, this can. That is correct. Yeah. So if you, for now, what it does, it actually sends a telegram every few seconds to the backend. This telegram is stored in the database, and then all the stored telegrams are being used in the calculation. So that's right. If you lose the connection to the backend, then the telegrams will be lost. It can be anyway. The telegrams can be cached. It's not very difficult. We are using a Raspberry Pi. It has 4 gigabytes of memory. So
just add some edge computing on the Raspberry Pi and you have a finished product.
Sure, we can.
Just
actually, we do some edge computing because we sample every second, but we send every minute.
Okay.
So we do aggregate the data that you sample.
So you could simply extend that and send it only when the backend is available.
Sure, sure.
Great, nice project.
Thank you very much for the question.
Thank you. Other questions?
Please.
It's about implementation of all the calculations. So I saw technology-wise some like SQL and so on. Do you really use that for calculating every time all the samples and aggregating something of that? Because I can imagine in a long term it might become relatively big data. So is it purely SQL?
Yes. Okay, so I will rephrase the question. So basically the question is if we have a lot of samples in the database, we may end up with a problem that the database is too full. Is that the question?
Yeah, because I guess...
Yeah, if we have 10 devices and each send every minute, in 10 years we'll have an issue, right?
Yeah.
Okay, so we also thought of that. You can have a job running on the server, and every information which is older, let's say, than 1 day, you can aggregate it still. So you can take the information that you received in the last 20 days and compile it into just one record. Because what you're after with this kind of installations is the 1 year history. Because you'll have a fluctuation between summer and winter all the time with solar. And also with the wind, you have some wind patterns that will fluctuate. But during the years, so from 1 year to another, if you, basically the patterns will repeat. So if you measure for a full year with this device, you will be able to have a very good picture of what's the potential of that location.
Okay, but the actual calculations and that follow-up, is that all kind of in memory, or is that kind of more in the SQL database that's computing all that stuff? Because I presume there's a lot of calculation going on to come with your conclusions. Or not really?
Well, right now it's straightforward calculation. You have some input variables which factor in the prices. Prices, as I mentioned during the presentation, the solar panel, the battery, the solar inverter, grid tie inverter if it's the case, wind power turbine, also the prices for the kilowatt in your country. So all these parts are input variables for the equation, and then at the end you get the result, which is a recommendation. So it's not very calculation intensive. We don't use very advanced mathematics for this.
I don't think it was a very good idea to ask the technical people to ask questions, because you can sit here for hours. No, I'm sorry, we're running out of time. So
if I may just...
No, you may not.
So
okay,
if you have any other questions,
take over.
You can find us at the Accenture booth.
I was going to say that. Thank you.
Okay, please go on. Okay, so we'll be there with the device and with all the answers for all your questions. I would be very delighted to have more technical questions, because that's where we, let's say, lay at. We like the technical side of the challenges. Okay.
Love it. Thank you, guys. Thank you very much. Well done.
Thank you.
And congratulations for winning the hackathon.
Did you know that 7 out of 10 Americans need to take prescription pills every day? Well, administered incorrectly, they can lead to even more health issues and increased costs for the patient. Taking multiple pills every day means that managing this task is very difficult, and we want to help with this issue. So let's think of my grandma, who recently had brain surgery. Now she needs to take 4 pills every day, administered at irregular intervals. Well, she's not very technically skilled, so we're not really helping her if we just give her a spreadsheet with her schedule. This is why we propose a digital voice assistant, which can help patients through natural voice interaction. And we believe this is very important, especially in cases in which the medical issue makes it difficult for a patient to use a device. We also offer an Android app for the doctor, in which he can manage the patient's data and see real-time information about the patient. So the features, our application's features allow the doctor to create the patient's profile through the mobile app and update the pill schedule, and the patient can instantly and always see the information up to date through Alexa. So let's make a quick demo. Alexa, hi.
Hi.
Alexa, ask Pill Assistant, what pills do I need to take?
You have to take 2 pills of Adapin, 3 pills of Advil. Are you going to take them now?
Yes.
Glad to hear that. On a scale of 1 to 10, how would you rate your pain?
1.
Glad to hear that. On a scale of 1 to 10, how would you rate your pain?
1. 1.
Please don't forget to take them. On a scale of 1 to 10, how would you rate your pain?
1.
Your data has been logged. Thanks.
She's just a bit shy. So, Another thing that we can enable is that a patient can send instant reports when he's not feeling well. Alexa, tell Pill Assistant I'm not feeling well.
On a scale of 1 to 10, how would you rate your pain?
9.
Sorry to hear that. I will notify your doctor.
And we can see that the doctor has immediately received a notification that states the health can see the state of the patient's health, and he can also see the patient's medical history and his evolution in time. Now, if the patient has an actual emergency, we can also send an instant notification to the doctor. Alexa, tell Pill Assistant I'm dying.
Sorry to hear that.
And the doctor has immediately received emergency notification and can choose to act upon it and send a medical team to the patient's location. So, yeah, so this is who we are. And do you have any questions related to our project? Well, no, but hopefully in time this technology will get translated and be available to everyone. Well, there are devices who can automatically dispense pills, and we could connect it to our solution. Any more questions? Yes? Well,
What's the next step is the question.
We could integrate our application with other devices that monitor the patient's health, like smartwatches for heart rate, or there are apps that can monitor food intake so that the doctor can see what his patient is doing and how he is feeling.